Alright, for this lesson we will continue working with circles and specifically tangents of circles and their properties. So for number 9, we're supposed to draw two circles that have the given number of common tangents. So I need to draw two circles that have 3 common tangents. If I draw my circles like this, if I draw the circles intersecting at a single point, that's going to create a situation where we will have 3 common tangents, because there will be one common tangent going like this, and there will be another common tangent going like this. I have to move that down. But there will be a third common tangent going right down the middle. Okay, so that's how we could have 3 common tangents. If I want two circles that have 2 common tangents, like it says for number 10, then what I'm going to do is I'm going to have 2 overlapping circles, because that will eliminate the possibility of a common tangent on the inside, in the middle. Okay, so if I have 2 circles that overlap, sort of like that, then I will still have the outer common tangents. Okay, that was a miss. Okay, so I'm still going to have this outer common tangent like this, and I'll have another outer, common external tangent going like this. But there will be no other common tangent because of the overlapping. It's blocking me from having a tangent, and it's blocking me from having any internal tangents. If I wanted a pair of circles that had 0 common tangents, we can make that happen by when we have a circle inside of a circle. Okay, those 2 circles will have no common tangents at all. Alright, so that's number 9, 10, and 11. Now we get into the meat of the meal here. Let's see. We're supposed to find, okay, we're given that BC is a radius, obviously. AB is a tangent, okay. We could have known that based on the fact that it was perpendicular. But the main thing is we are supposed to find the value of x. So it's going to be all about the Pythagorean Theorem. Let me zoom in a little bit more so I have space. Okay, so the bottom line is Pythagorean Theorem, my good people. So here we go. So a squared plus b squared equals c squared. So this is going to be like x squared plus 96 squared is equal to 100 squared. Subtracting 96 squared from both sides, that's going to give me x squared equals 100 squared minus 96 squared. And then I like to just take the square root of everything right here, just like this. Square root of it all. So that's going to give me x equals, and that's how it would look in the calculator, 28. So x equals 28. Alright, that's it for number 12. Same type of deal for number 13. Once again, we're just going to do the Pythagorean Theorem. That's really all we're going to do. So this is going to be 45 squared plus 108 squared is equal to x squared, that hypotenuse there. Just going to take the square root of both sides like I did before. This time I don't even have to subtract anything. Just put all that in my calculator. In the calculator it looks like this. That's 117. And that's it for number 13, just a little Pythagorean theorem. So you know what? This stuff is pretty straightforward. So once again, leg squared plus leg squared is equal to hypotenuse squared. And once again, I'm going to subtract 48 squared from both sides. So that's going to give me x squared is equal to 80 squared minus 48 squared. And I will take the square root of both sides in this form. I don't like to take the time to square this and square that. It's just unnecessary. Why do it? Let's just let the calculator do the work. I don't think of it as being lazy. I think of it as being efficient. And in your calculator, it will look like this. And you get 64. So x equals 64. All right, well, this is going rather swimmingly. Let's see, number 14 means there must be number 15. Okay. Now, slow down. So that was the easy version. This is going to be one level more complicated. Look at the difference here. The difference is, in the previous problem, we were given one expression for the entire hypotenuse, just a single number. So for example, for number 12, the hypotenuse was simply 100. For number 13, the entire hypotenuse was x. And for this one, the hypotenuse was 80. You can tell that this x is supposed to represent the entire hypotenuse because of these arms that are reaching out all the way from A to C. Same thing on all the problems. I can tell this 100 is the whole hypotenuse because it has these lines reaching out, showing that the 100 stretches all the way across. Now, without those lines indicating the reach across the entire hypotenuse, then it is not the entire hypotenuse. So when we look at number 15, the hypotenuse is in two pieces. The inner part here is x, you know, that's like one piece, the radius. But then the outer part here is 16. Okay, that's two different things. So if I want one expression for the entire hypotenuse, I'm going to have to add. So the whole hypotenuse is x plus 16. So I'm still going to do the Pythagorean theorem, but I have to deal with this binomial now, this x plus 16 for the hypotenuse. So let's see how that works out. So Pythagorean theorem will set up this way. X squared plus 32 squared is equal to, now I've got this binomial for my hypotenuse, so I have x plus 16 squared. Now, the most common mistake that students will make is thinking that the way you square x plus 16 is just to square the x and square the 16. And so we'll have a new binomial here with x squared plus, you know, whatever 16 squared is. But that is not how you do it. That would not be accurate. What it really means to square something is to multiply that thing by itself. So x plus 16 squared means x plus 16 times x plus 16. Okay, I'm just going to bring this part down. X squared plus 32 squared. I guess I could turn this into a regular number now. I think I will. See, 32 squared, 1024. Let me go ahead and make that change. Make that change. Gonna make a change. So let's see, 1024. Now, to multiply these two binomials together, again, I'm not just going to do x times x and 16 times 16. Some teachers in the past might have taught this to you as the FOIL method. Maybe you've seen this acronym before, FOIL, and that stood for first, outer, inner, last. Some teachers just look at it as doing the distributive property twice. Either way, it's really the same thing. let me just put lines to show you what we're doing. Either way, what you really do is you take this x and you multiply it by both of these things. So in other words, x times x, that's going to give me x squared. And then if I do x times 16, that's going to give me 16x. But then I take the 16 and I distribute that as well. Okay, 16 times x is 16x. 16 times 16, I don't have memorized, you know, but that's the same thing as 16 squared. That's 256. I probably should have known that. So that's 256. So this is what you get. Notice it's not the same thing as just x squared plus 256, which is what we would have gotten if we had just squared this and squared this. There's this middle term that we get, and we can simplify this a little bit more. So this will be x squared plus. And of course, 16 plus 16 is 32. So let's go ahead and put 32x plus 256. Alrighty then, and I'm just going to bring this down. So x squared plus 1024 and x squared plus 1024. Now we can go on and solve this thing. We need to get our terms together. So see how I have x squared on the left, x squared on the right. To get those closer together, we will subtract. So minus x squared from both sides. Well, those actually wind up completely canceling each other out, which is convenient for us because it makes life simpler. So that'll be 1024 is equal to 32x plus 256. The rest of this should be pretty easy to solve. Subtract 256 from both sides. Kabam. All right, 768. And then, of course, we're going to divide both sides by 32. Hmm. 768 divided by 32. 24. And there you have it, ladies and gentlemen, x equals 24. Now, what I recommend to you is, you know, if you're watching this video and you didn't really know how to do number 15, and so you just kind of watched me do it, this now should be your turn. So do not just continue to sit there like a potato and just watch me. Pause the video, do number 16 by yourself, and then check in with me and see if you got the right answer. Alright, there's no point in just watching me do another problem. So pause the video now and do the problem by yourself. You'll feel better about it. Okay, let's pretend that you did that, and now we are back. So the rest of these other two problems are going to be pretty much exactly the same as what I already just showed you. So let's just do it again. So this is going to be like x squared plus 56 squared, just doing my Pythagorean theorem. But then, just like before, the hypotenuse is a binomial. So it's x plus 32. It's going to be the binomial for that. So it'll be x plus 32 squared. So that's going to give us x squared plus 56 squared is equal to x plus 32 times x plus 32. So that's going to give me x squared plus, you know what, let me go ahead and do that this time. 56 squared. Um, 3,136. Equals. And again, I'm going to do this distributive property, FOIL, whatever you want to call it. But that's going to give me x squared plus 32x. I'm going to do it again with the 32. And that's going to give me 32x plus, and then 32 times 32. I could have just put 32 squared. Is 1024. Did I just do that before? The number looks familiar. Okay, so that's going to give me x squared plus equals, that would be 64x, alright, I'm just combining these like terms, plus 1024. Okay, so time to subtract x squared from both sides. And again, those completely cancel each other out. Very convenient. So that's 3,136 equals 64x plus 1,024. Let us subtract 1,024 from both sides and see what we get. Alright, so that'll be 64x equals. Alright, and then it's time to divide both sides by 64. Alright, 2,112 divided by 64. 33. So x equals 33. Okay, not too shabby. Alright, let's do number 17. Once again, it's really the same thing. So here we go with our Pythagorean theorem. So it's going to be x squared plus 63 squared is equal to x plus 49 squared. Because this is the exact same thing as what I just did, I think I'm going to do this in time lapse, fast forward motion. All right, looking at number 18. There's a property of tangents. If you have two different tangents, both coming from the same point, then those tangent segments will be congruent, which sets us up for some really easy math, because that just means these two expressions will be equal. So that means that 7x minus 8 is simply going to equal 4x plus 7. And, so subtract 4x from both sides. So that's going to give me 3x minus 8 is equal to 7. Add 8 to both sides. So that gives me 3x is equal to 15. Divide by 3. It's going to give me x is equal to 5. So pretty simple and easy. Similarly, okay, but not quite so easy, these two will be equal to each other. So that means 3x squared minus 10 is equal to 17. Let's see how this turns out. Let's add 10 to both sides. So that'll give me 3x squared is equal to 27. Let's go ahead and divide both sides by 3, like so. And that is going to give me x squared is equal to 9. All right, that's not too bad. Take the square root of both sides, and that gives me x equals, now normally I would say positive or negative 3. And maybe I still will. Yeah, I still will. Okay, so if you take the square root of both sides, the solution is always going to be positive or negative. I was just pausing to see if x represented a length. We know that lengths cannot be negative, so I would have ignored the negative answer if x was length. But x is not a length, it's being squared, so that's going to be positive no matter what. So that means 3 and negative 3 will actually work in this situation. So 2 answers, positive or negative 3. Again, anytime you take the square root of both sides, the solution, there will be 2 solutions, one positive, one negative. So one more time, but perhaps one more level of difficulty. X squared plus 3x minus 2 is equal to 3. This time I have an x squared term and an x term. That tells me there's no way I'm going to just get x by itself. So instead of trying to get x on one side and everything else on the other, I'm going to put everything on the left side. So in other words, this time I'm going to subtract 3 from both sides. And that's going to give me 2x squared plus 3x minus 5 equals 0. And then I am going to factor this. Okay, so this is going to be 2x and x. And so I got to play around with this a little bit. It's probably going to be 5 and 1, positive 5, and negative 1. That will work. So that's how you would factor this, and then I have to set these equal to 0 to get my 2 solutions. So 2x plus 5 is equal to 0. X minus 1 is equal to 0. Now look, you know what? I kind of glossed over the factoring part. I just kind of did it. The thing is, to explain the factoring, that needs to be a whole lesson by itself, if that's something that you need. So I will ask in class, and I will probably wind up making an entire video just showing and teaching how you factor. But for now, I'm just going to keep going. So if I set both of these equal to 0, I'll get my 2 solutions. So subtracting 5 from both sides, so that'll be 2x equals negative 5. Divide by 2. Alright, and that's going to give me x equals negative 5 over 2, or negative 2.5. So let me put a box around that. On this side, you know, I'd add 1 to both sides, so that's going to just give me x equals 1. So I have these two solutions. Now, this one's negative, so I really want to go back and look and make sure that that's going to be okay. Okay, I need to make sure that this will give me a valid answer. In other words, if I plug in negative 5 over 2, you know, that'll be fine. All right, so I just have two solutions. Okay. All right, these last two problems, even though they are word problems, they are really the same as the problems that we've been doing over and over again. So I went ahead and worked them out off camera. So I'm just sort of going to scroll through the solution, make a couple of comments, and trust that you get it because it is the same. So all of those words in the word problem really boil down to looking at this picture, and we're being asked for the radius. We're asked to find r. So just like in all the other problems, the hypotenuse here is a two-part hypotenuse. We've got the r and the 36. So there's our r plus 36. So once again, we're going to do our a squared plus b squared equals c squared, which gives us this equation. R squared plus 48 squared equals r plus 36 squared. If you square the 48, do your double distributive property, you get this. Combine like terms, you get that. Subtract r squared from both sides. So then you have this. Subtract 1,296, you get this. Divide by 72, you get this. So just look over this solution and see if you can understand, because really it's just like the other problems that we've done. I'm going to move on because this video is already getting a little too long, but you can pause the video and study this solution if you need to. Alright, I'm going to assume you did that if you needed to. Now I'm going to move on to the last problem. Okay, this one is slightly different, but in a way that's actually easier. Suppose that a space shuttle is orbiting about 180 miles above the Earth. So let's absorb that part first. This 180 miles above the Earth, we're talking about the surface of the Earth is just right here at the edge of this circle. So this dot is supposed to be the satellite. So this small red segment that I've drawn, that is 180 miles. Okay, doesn't look like 180 miles because it's so tiny, but that is 180 miles above the Earth. Now, of course, this is a radius of the Earth, and this is a radius of the Earth, both of these lines. So that means, as far as this right triangle, the whole hypotenuse will be r plus 180, the radius plus 180. But we're given more information. We're supposed to find the distance d from the shuttle to the horizon, but we're told that the radius is about 4,000 miles. All right, the radius of the Earth. So this, where I put r, we know what that is. It's 4,000. So that makes this side of the triangle 4,000, and that makes the hypotenuse 4,000 plus the 180, r plus 180. In other words, the hypotenuse is 4,180. Now, I just recopied this equation over here, this picture over here to the left, just to make it a little bit more clear. The bottom line, we have a right triangle, and we're supposed to find D, which is one of the legs, and we're given that one leg is 4,000, all right, because that was the radius, and we figured out that the hypotenuse is 4,180 by adding these two together. So it's once again, it's just the Pythagorean theorem, but this time there's no binomial, it's just normal. So 4,000 squared plus d squared equals 4,180 squared. Now, rather than squaring this and getting these huge numbers to write down, I find it easier to leave it as 4,000 squared and just subtract that from both sides. So that will give me 4,180 squared minus 4,000 squared. And then I just take the square root of both sides, and I just put this entire expression, you can just put into your TI-30 XS multi-view. And you should get 1,213.4 miles. Now, I put 0.4 because they said the nearest tenth, that's 1 decimal place. All right, that is it for this lesson. If this has been helpful to you at all, I hope that you will go ahead and do me a favor. Give me a thumbs up. Hit that like button. And what that does is it helps me kind of get the word out there. I want to help as many people as I possibly can. And but right now, most people don't know that I exist. So it will help the channel grow and help get the word out there so I can help more people. Okay, thank you so much. I am eternally grateful. See you around.